Welcome to this info video tutorial. In this video we will cover DTMaster DSM Workflow, and we will continue with the previous video that was covering the DTM Workflow and use the data we processed with match-t. As mentioned, the workflow for the DSM is a different one, and we need different ways of editing to create our final product, which is still a terrain model in our info software world. So the DSM generation is very useful for city areas, but still we focus on the creation of a terrain model. Reasons why we still need the dense point cloud are given in the previous video, where we shown that the DTM extraction is very undulating, not covering the streets to the bottom. The buildings itself are not sharp, and therefore the dense point cloud allows us a very automatic workflow for this purpose. The workflow will be following. We need a tiled data because the point cloud can be very large. This was already done in the match-t DSM, where we automatically tiled the data. In case you didn't do it, you can still do this again in DTM Toolkit. And in DTM Toolkit we will classify the data into ground points and off-ground points, which will then look, in this case, following that our point cloud that we generated in match-t DSM is unclassified, and then we will move the points into different classes. And because we work with the LAS format, this can all be stored in the same LAS file, so the point is still in the same file, it just gives a different class value, so we know it's not anymore on the ground. Then we will go into DTMaster. We will do editing for still the points that are wrong. We will need some gap filling, and then afterwards we check the result and we create our terrain model. So let's start with the classification. We close DTMaster here. So let's start with the classification. We will use the DTM Toolkit. You can find the DTM Toolkit at Capture DTM Toolkit. We will use the point vector data processing, and we will start with the filter classify function. We add from our match-t run from the DSM video the shapefile. It will store the data in the same LAS file, so it will just filter the data and classify it into the same LAS files. We will not use morphological data. We drag a polygon and select all the tiles, or you can also choose here deselect, select all the tiles. We will run the match-t DSM fast filter. We will use as grid width 0.5, mean accuracy 20 centimeter, and I will discard many points, so to keep only lesser ground points which are more sophisticated on the ground. And that's it. I will show you then the final result. The filtering classification is finished. It was successful, and we can now start DTMaster. In DTMaster, this was from my previous video. In DTMaster we import now the shapefile, so we will use the tile manager. This is different than in the DTM workflow. Because the data is stored in multiple LAS files, we will work with the tile manager. The folders here were generated from the DTM toolkit filtering. It includes some parameters. The tile navigator gives us an overview of our 4 LAS files. Currently the LAS files are not loaded. This is just a template that displays us approximately how the data looks like. We will work on the lower left one because here also was this city part area we worked in the DTM workflow. And we can select the tile and load the data into DTMaster. And we can see the data now in DTMaster loaded. Let's navigate to the area we worked in the DTM workflow part, which is this city part here on the top right corner. We can use the same displaying functions, so we can switch off the points, use the shaded relief, use the Z coding on top of it. Additionally, here with the DSM workflow we can also use display colored points, because each point was matched in the aerial images and we have a color information for each point. If we take now a look at the same area like in the DTM and we open here a profile view for this part, we can now see that the points mostly are already correctly classified. Let's take a look here. If we take a look at the terrain tab, we can see now here the ground points in blue. Then we have here the buildings in red, the high and medium vegetation in green, and also the low vegetation, the low points, and we still see some wrong classified points, but as mentioned, this is really only now a small portion of data that is wrong, which we can now easily classify into the correct part. We can select the points, move them into high vegetation, and we already have now our terrain model, because if we overstretch it by 1, then we see this is really just a small part of points that are not perfectly fitting on the ground. This was possible because when we display the points again and we display here the colored points, then we see now that the point cloud is very sharp, making a distinction between ground and off ground. If I overstretch it, we can see it perhaps a little bit better. So it's very easy for the system now automatically to distinguish between ground and off ground. So let's switch off for low points, building points, high vegetation, medium, low, the interpolation flag, and let's display here only the shaded relief with the contour lines, and we will switch the color from the contour lines to red and make the selection purple. And we can now check the data for some offsets. So we see here, if we use here for example half meter contour lines or 1 meter contour lines, we have here small bumps. And here we can now check the data, open the profile view, see that there are some points wrong classified and they are not ground, so we can select the points, they are low points, and let's see what they are. They are low points. And then we can check here for further parts. We have here also an untypical contour interval looking at, and also here we see we have some low points, and here we can again select the points, classify them into the low points, and check our data for correctness. And if their data is more complex, it makes sense to open a larger part of the profile to investigate how the complete part looks like. And we see here the terrain looks more like this part here. If we are not sure, we can always check in stereo, look at the data, see where the data is located, and we see here the vegetation was here introduced as ground additionally. So this is not a building, it's high vegetation. So we can classify these points into high vegetation and fix this part here. The remaining part looks fine. And then we already have here, okay, there's a small bump here, which is here below. And also here we have a small bump. Okay, also have some high points. But also some low points. And here 2 more to go. We can also add a selection by selecting multiple times. And then we are already done with the editing of the ground points. Let's take a look. So we did the quality assurance and quality control of our ground points. Editing is needed. There are still some errors in the automation, but we almost done it in a very quick way. The quality is very good. We have a very accurate terrain model for the ground in the city part. And we can continue now with the next part, which is filling the gaps. We don't want to have here these gaps. And we have an automation tool called Interpolate Gap Project. And we have to decide how dense we want to fill the gaps here. We can always check how dense our point cloud is. So you can zoom in and we can measure with the tool here the distance between the 2 points. And the distance between 2 points here is 50 centimeters between the 2 points approximately. And we can either fill with 50 centimeter. It's up to you if you want to use the same density. I will only use a 1 meter so that I have a difference between my automatically matched points and my synthetic generated points. I will place them into ground synthetic. Use a 1 meter grid spacing and start to fill the gaps. And after the gap filling is finished, we will review the result and see if there are still some offshots or some bumps in it. And here we need a second visual control. So a second time we will need to go for the data. And you see there are still some parts that are not correctly filled. For example, here inside these parts here we have here a jump, and we see I forgot that this building is not correct. Luckily for me, the ground points, synthetic points were correctly placed. And then you either can undo everything of the gap filling, or we just select the points and use the reinterpolate function to place it correctly on the ground. And again, we would now need to go through the whole data set, check these wrong gap filling parts here, this part here, these little bumps here. Of course, when we zoom in, we see more details here. So there's here an error, there's here an error, and here are also some errors. And we would need to fix all of them, but we see it's not too much, it's a few small parts. And then we are done with the quality assurance of the gap filling. And that's it. Then we can say, okay, this is fine. Let's go back to the tile manager. And this data we have here now, we will commit the data. So all the changes we have done to the point cloud, we write it back to this LAS file. So I say do it, commit, and all the changes I have done, they are now stored in this one LAS file. And then I can say here, okay, tiling was already done. We see it's filtered already, but we also did the gap filling. Let's assume we completed it. It was really well done from us. Also, we did the filtering is completely done. Well, it's already here mentioned. Sorry, the editing status we want to change. So here we are done with the editing of the DTM. No, sorry, wrong for me. Tile status. So this was edited. And so for me, I can now log the status. I can see, okay, this one is completed. I did the editing. And then we can continue with the next one here. So we can either we can now just select this one and load it, or we can also use here the arrow keys. If I use the up arrow key, it will automatically unload this tile and load this tile. Let's do this. So the data is removed from this part here, and this data here is automatically loaded into DTMaster. And we can see now that the data is loaded here in the back part, and we would then again do the same procedure. We would again search for errors in the ground points. After we corrected all the errors, then as mentioned, we will then use the gap filling, and then again we check the gap filling. If we have to make their corrections, we will also do this one. And so again, after this tile is done, we go to the tile manager, and we then commit again the data to the LAS file. This is the part where we finish with DTMaster, and then we can create now with the edited tiles our surface model in the DTM toolkit. And this can be done again from the applications master. We start again capture DTM toolkit. We go to the point vector data processing. You see there's also a gap filling option here, but this was newly introduced into DTMaster, so we don't need it anymore from here. We could do it also here, but we don't need it. And we will use the surface modeling. We will add our shapefile. Again, this shapefile is the one we have seen in the tile manager in DTMaster, giving us the tile information, how they are located. And these are the data. This is the data itself, and we overrode in this case the tiles. For example, you see the timestamp here changed to 3:37, and this last file now was the one that I was working on. And we can now load them here. Again, the surface modeling output will be here in the same folder. We can consider morphological data. We will not do it. We select all the tiles, and we will now create here 1 meter DTM. We could also generate a 50 centimeter if we want, but we will use here the 1 meter. And we will only use the ground points, but also we will consider the fill points. And this is important that we use for the gap filling the layer name ground synthetic. So the points need to be in ground synthetic, and then they are considered now for our purpose here, and our ground points, they are in the layer ground points. And that's it. We will say next and start, and then for each tile 1 scope DTM is generated. So we have 4 LAS files, and therefore we will have afterwards 4 scope DTMs. Okay, we generated our scope DTMs for each LAS file, 1 scope DTM. So we have here 1 scope DTM here, 1 scope DTM here, 1 scope DTM here, 1 here, for each of the LAS files. We could also then merge them if we want together. This is done by using the DTM processing merge. Again, we could select the TPX shapefile, and here we can generate 1 final DTM. Let's call it here merged. And again, we select here the tiles, and it will automatically detect the tiles, the grid size from the scope DTMs. We can here merge the border lines, and from the 4 DTMs we will now also have the 1 final DTM. Let's just take finally at DTMaster a look at the result. I will just kick out here the result from last time, and we import here now with quick load the data. I will first only look at the 1 tile that we edited, which was the one at 337. So it's the 10.000.000. So this one here. Let's take here this DTM view. This was the one with the buildings here included, and so this was the part here where we had the buildings, and we see now it's a nice and clean DTM, also still including a lot of detail parts. Of course, I did not do all the editing, so I would have needed to do the editing here on this part, or let's keep with the shaded relief, and of course here I did not do the editing part. But everything else here includes a lot of detail. You see still the footprints of the buildings partly even, and as mentioned here, this part where we have here the city area is nice and clean. And if we take a look at the complete one, of course this one is not correct because I did not do the editing for the remaining ones. And then we see, of course, here that they have still a lot of errors here included in these parts, or here you remember I made the gap filling, but I did not, I did the filtering, but I did not fill the gaps, so this is still missing here, and therefore the cleanup of this part is not so well done as the other one. But I hope you get the attention. This is now an option to get a very accurate terrain model. You see also with hilly parts in the city area. So we have here also a mountain part, which is well introduced, and if I would have cleaned up this part, it would have really been a very, very good terrain model for a city area. And with this scope DTM we can continue our work process in the info world, and this is shown then in further videos. Thank you very much for watching this video tutorial. Goodbye.